All right, welcome to another episode of Math with Mr. Young. Today we're working with 5.2 writing expressions. Our standard is 6th grade evaluating expressions A, and by the end of this lesson we will be able to write algebraic expressions and solve problems involving algebraic expressions. Our mathematical literacy, we have algebraic expression, variable, term, coefficient, and constant. All right, for 5.2 writing expressions, our success criteria is that we will be able to write numerical expressions as well as algebraic expressions. We will also be able to write and evaluate algebraic expressions that represent real-life problems. For our mathematical literacy, we have our math vocabulary words. We have in the first column the operation, and by that we mean we're going to look for keywords and phrases. And then we have these keywords and phrases for each operation, additions and operation, and what tells us to add is added to, plus, sum of, more than, increase by, total of, and. They tell us to add. Keywords and phrases for subtraction, subtracted from, minus, difference of, less than, decrease by, fewer than, take away, all tell us to subtract. For keywords and phrases for multiplication, multiplied by, times, product of, and twice all tell us to multiply. And lastly, for division, the keywords and phrases that tell us to divide are divided by and quotient of. So make sure you take a picture of this and maybe have that handy or write these down, and let's go ahead and get started. All right, for this example, we're going to write numerical expressions. Now, numerical. Now, when we talk about, or numerical, numerical, potato, tomato, tomato, it doesn't matter how I say it, it's the same way. So, numerical, we're talking about numbers. So, expressions that have nothing but numbers in it, okay? So, here we go. Our directions tell us to write each phrase as an expression. So, again, we have 8 fewer than 21. So now we're going to write the numerical expression. 8 fewer than 21. So again, we have 21. Again, we have 8 fewer than. Fewer than tells us to subtract 8 fewer than 21. So 8 fewer than 21 would be 21 take away 8. The difference would be 13. Okay, so we have the product for B, the product of 30 and 9. So again, we're going to circle this. This is a keywords and phrases. Now, when we talk about products, we're talking about multiplication, okay? So we're going to set this up. The product of 30 and 9. So the product of 30. So the product of tells us to multiply, okay? And then we multiply 30 times 9. So 30 times 9, again, we're just writing the phrase. It doesn't tell us to evaluate. We're taking it a step further, okay? But 30 times 9, 9, 18, 27, and then add your 0. So there you go. Okay, so what we're doing is we're evaluating. It doesn't say to evaluate, it just wants us to write each phrase as an expression, a numerical expression. But we're taking it a step further to evaluate, meaning that we're solving these as we go. Okay. Now here we have the sum of 18 and 35. So the sum of tells us to add. So we have the add-in 18 plus the add-in 35. We get the sum 53. Then for D, 6 times 50. Again, times tells us to multiply. So 6 times 50. Now, if you cover your 0, 6 times 5 is 30. But then just bring the other 0 down. So 6 times 50 is going to be 300. All right, again, we're taking it a step further by evaluating. All right, for this example, we're going to write algebraic expressions. Now, the only thing that's different between numerical expressions and algebraic expressions, you see that numerical expressions, you have nothing but numbers. There's no alphabets, there's no letters. But with algebraic expressions, there's alphabets and letters. Okay, so let's look at this one. For A, B, C, and D, we're going to look at A. So the directions tell us to write each phrase as an expression. So in A, we have 14 more than a number X. Okay, so that's going to look like more than tells us to add. Okay, so 14 more than a number X. So whatever X is, we have 14 more than X. Okay, for B, we have a number Y minus 75. The word minus tells us to subtract. Okay, so a number Y, whatever Y is, we're going to subtract 75. Again, we are writing algebraic expressions. Now again, just to recap, with algebraic expressions, algebra, we're working with letters or alphabets for a missing value for these variables. When we write numerical expressions, we don't have alphabets. We just have nothing but numbers, known values. Okay. All right. So for C, we're going to write the quotient of 3 and a number Z. Okay. So the quotient of 3 and a number Z. So the quotient of, the phrase quotient of, tells us to divide. So the quotient of 3, okay, the quotient of 3 and a number Z. Okay, or you can say a quotient 3 and a number Z. All right, again, whatever the number Z is, that's what we mean a number Z. Z is a variable that for an unknown value. This is not a 2, that's a Z. Okay. And lastly, for D, 25 less than a number B. So less than tells us to subtract. Okay. 25 less than a number D. So we're going to subtract. All right. And then, okay, 25 less than a number B. All right. So whatever B is, whatever the value B is, we're going to have 25 less than that. All right, there we go. We just wrote some algebraic expressions. So the same thing, we're going to write an algebraic expression, but this time we're given a statement or a paragraph of a situation. So down here we have different options, A, B, C, and D. So all of these are different answers, and it looks like we're going to have to pick one of these by solving this problem up here. So let's listen up. So the length of Interstate 90 from the west coast to the east coast is 153.5 miles, more than 2 times the length of Interstate 15 from Southern California to northern Montana. Let M be the length of Interstate 15. Which expression can you use to represent the length of Interstate 90? Okay, so the word times means to multiply. So 2 times. So that means to multiply. The phrase more than means to add. Okay. So again, if you listen closely, the length of Interstate 90 from the west coast to the east coast is 153 miles more than. So that's going to be 153.5 miles more than 2 times the length of Interstate 15 from Southern California to northern Montana. Let M be the length of Interstate 15. All right, so there you go. We just wrote an algebraic expression from this situation. Now, the algebraic expression is 2m plus 153.5. Do we see that anywhere? Yes, we do. The correct answer is going to be B. Okay, so now we're going to model real life. So we plant a cypress tree that is 10 inches tall. Okay, so we're starting with 10 inches. We're planting a cypress tree that's 10 inches tall. Each year its height increases 15 inches. So every year it grows 15 inches. We're going to write an expression. It could be numerical, could be an algebraic expression, but we're going to write an expression that represents the height in inches after t years. So it looks like this is an algebraic expression because there's a variable t. What is the height after 9 years? Okay, so things that we do know. Well, I do know I need to make a table. We know that each year we're going to have t, I guess for time, and then we're going to have the height, but we're going to have it in inches. Okay. All right, so we just got this plant, and we know that the plant is 10 inches tall. Okay, so technically no years has gone by yet. But the first year we have it, we know it's 10 inches tall, but let's see here. Each year its height increases by. So right here, increases by. Again, if I can find that one paper. Increases by. Increases by tells us to add. So this is it increases by 15 inches. Okay. And that's for every 1 year. All right. So if we look at this, 10 plus 5 is going to be 25 times 1 is just 25. So after a year, that tree is 25 inches tall after a year. After 2 years of having it, 15 times 2 is 30. 30 plus 10 is 40. After 2 years, it'll be 40 inches tall. After 3 years of having it, you guys see a pattern developing? 15 times 3 is 45, plus 10 is 55 inches tall. After 4 years of having it, okay, 15 times 4 is 60, plus 10 is 70 inches tall. Okay, so there's a pattern. But it says, what is the height after 9 years of having that cypress tree? Well, let's put 9 years here. 15 times 9, and then we'll figure that out. Okay, so we do that. Let's see here. 15 times 9, that'll be 135, plus 10 is 145 inches. So what is the height after 9 years? In 9 years, the cypress tree will be 145 inches tall. Boom. All right, there you go. Easy peasy lemon squeezy. So thank you guys for being here, and we're going to have some fun writing expressions, numerical expressions and algebraic expressions. All right, so by now you should be able to write algebraic expressions. You should also be able to write numerical expressions. You should also be able to write and evaluate algebraic expressions that represent real life problems.